The night sky had always seemed eternal, unchanged, a canopy of familiarity over a restless earth. But then, in the stillness of early 2020, a flicker of light was traced across the cold abyss, faint, fractured, and forgotten by most who lived beneath it. Astronomers knew it by a sterile designation, 3I Atlas, the third interstellar wanderer ever witnessed. Yet behind the catalogue name lay something stranger, something whispered rather than announced, something that would unsettle the most seasoned minds. For millions of years it had travelled, an exile from another sun, another system, carrying dust older than Earth's continents, perhaps older than the sun itself. It had endured the slingshot of forgotten orbits, the slow erosion of starlight, until at last it crossed the invisible border of our solar neighborhood. But unlike Oumuamua, its sibling in strangeness, Atlas bore scars. It seemed to come not intact, but unraveling, as if reality itself had frayed it apart before it arrived. Through telescopes it shimmered a broken traveler, trailing fragments like the feathers of a burned bird. Its path was fragile, but the mathematics behind it more fragile still. Gravity tugged it one way, heat tore it another, yet its pieces did not obey the predictions of celestial mechanics. Some said it was ordinary, just another comet, its icy bones undone by the Sunday. Others saw the subtle betrayals, the unexplained drifts, the growing suspicion that this object was not what it seemed. And here, at the very edge of human knowledge, the narrative began to shift. What if this interstellar ghost was not simply a comet but a messenger? What if its disintegration was not decay but signal? What if, in its breaking, the fabric of reality itself trembled? The sky holds its secrets in silence, yet in 3I Atlas, silence was pierced by unease. Something had arrived that did not simply pass through the solar system, it seemed to question the rules that bound the solar system together. It is rare in the vast theatre of the cosmos for humanity to recognize a visitor not born of our own Sunday. The first was Oumuamua in 2017, a shard of mystery slipping silently between the planets, leaving behind more questions than answers. Barely 3 years later, another came, 3I Atlas. Unlike its predecessor, this interstellar traveler did not arrive sleek and enigmatic, but already fractured, as though the stress of an alien voyage had torn at its body long before it reached us. At first, its light was almost lost in the ocean of stars. Astronomers working with the asteroid terrestrial impact last alert system, Atlas noted the faint glimmer, cataloguing it as they had countless other objects. Yet the calculations soon betrayed its identity. Its orbit was hyperbolic, stretched beyond the sun's grasp, a trajectory not born of this solar system. Its speed told the same story. It came from elsewhere. But the strangeness lay not just in its origin. As the telescopes followed its fading arc, they saw something unsettling. Atlas was falling apart, far too quickly, as though some unseen law was pulling it to pieces. Ordinary comets break apart near the sun, undone by heat and tidal stresses. Yet Atlas fractured even before its closest approach, long before the sun's furnace could tear it open. It seemed to announce itself not as a whole traveler, but as a ghost already disintegrating. What made scientists pause was not only the crumbling of its nucleus, but the irregularity of its fragments. Pieces drifted apart, not in clean trajectories, but in chaotic, whispering motions. Some drifted faster than they should have, others lingered as though tethered to invisible threads. Its trail shimmered not like debris, but like a riddle written in dust. For those who looked carefully, it was a signal in the void, a message written not in words but in defiance of expectation, a comet that broke the rules before it even met the Sunday. The story of 3I Atlas begins not in the poetic silence of the cosmos, but in the watchful eyes of the instruments that never sleep. It was the Atlas survey itself, a pair of modest, wide-field telescopes stationed on Hawaiian soil that first captured its fragile glimmer. These telescopes were not built to chase beauty. They were guardians, scanning the heavens for anything that might fall upon Earth unannounced. Their task was pragmatic: to catch the faint signatures of asteroids, to map threats before they struck. Yet in March of 2020, they traced something more than a potential hazard. They traced the faint, cold light of an interstellar fragment that bore no allegiance to our Sunday. The astronomers who confirmed its path measured, recalculated, and compared against the motions of ordinary comets realized quickly that they were not watching something local. Its velocity was simply too high, its orbit too stretched. Earth, the Sun, the planets, none could claim this wanderer. It came from elsewhere, from a silence so deep that even its origin point could not be traced. Among the first to raise their voices were scientists still carrying the echoes of Oumuamua's arrival. They knew the signs of an interstellar guest, and they saw them again in Atlas. But where Oumuamua had been enigmatic, slim and intact, Atlas was broken, fragile, a story already half erased. Astronomers like Kwanzi, who had studied its fragments, noted its rapid demise, remarking that it seemed almost eager to vanish before it could be known. The discovery itself carried a quiet drama. Images of its crumbling body spread through scientific circles, revealing a diffuse smear where a nucleus should have been. Its once coherent form seemed undone, its core dissolving into smaller pieces, like a pearl ground to powder by invisible hands. Each fragment followed its own arc, but together they painted a picture of something out of place, something reluctant to be measured. And behind every data point lay a human story, observers staying up through the night, calibrating instruments, chasing a faint smudge through the noise of stars, knowing they might be watching a secret from beyond the Sunday. The first eyes that saw Atlas knew they were not just tracking ice and dust. They were watching a ghost from another system unravel before their gaze. When 3I Atlas began to fragment, astronomers at first leaned on the familiar. Comets break apart. It is their fate. Heat seeps into their porous ice, building pressure until the fragile body crumbles into shards. But Atlas did not play by those rules. Its nucleus shattered at a distance where comets usually remain intact. Long before the sun's heat could have reached deep enough to split it, pieces were already adrift. The break was sudden, like a frozen crystal shattering in a quiet room. 4 large fragments first appeared, then smaller ones, cascading into a cloud that expanded with unnatural haste. Each new observation revealed further unraveling, as though the object was eager to erase itself. Yet the violence of its fracture raised suspicion. Why did it collapse so soon, so chaotically, so defiantly of the neat predictions made by cometary physics? More troubling was the choreography of its debris. Instead of dispersing with uniform momentum, as physics textbooks would dictate, some shards raced ahead, others slowed, some curved in ways too delicate for chance. Their separation velocities were inconsistent, at times almost whimsical, as though governed by a hidden hand. Researchers spoke of irregular sublimation, of jets of gas escaping at odd angles. But in whispered corners of speculation, the possibility emerged. What if the fragmentation was not random, but purposeful? For a brief moment, the solar system hosted a cloud of interstellar material, behaving unlike any comet seen before. Not a tidy death, but an unraveling that unsettled the equations. The mystery deepened. Was Atlas merely fragile, or was its breaking apart a phenomenon entirely unmoored from the familiar laws of celestial mechanics? The sky had delivered a puzzle in pieces, and those pieces refused to fit. Only 3 years before Atlas, another messenger had passed through. Oumuamua, the first recognized interstellar object. Its elongated, tumbling body had defied neat categorization, not quite a comet, not quite an asteroid. Some saw in its erratic acceleration the faint hand of radiation pressure. Others dared to whisper of artificial origins. It was a riddle left deliberately unfinished. Atlas, by contrast, seemed almost too forthcoming. It arrived not intact but breaking, bleeding its enigma into the void. Yet the echoes of Oumuamua haunted every observation. Both objects bore the mark of exile, crossing into our solar system on hyperbolic paths, destined never to return. Both carried the weight of origins lost among the stars. But where Oumuamua had slipped past like a shadow, Atlas lingered in a slow dissolution, giving humanity a closer, though stranger, view of interstellar debris. The comparison unsettled astronomers. Oumuamua had been extraordinary because it survived the sun's embrace and left us guessing. Atlas was extraordinary because it did not survive, its fragile heart undone far earlier than expected. Together, they suggested that interstellar objects might not conform to the behaviors we expect from local wanderers. Perhaps these were not simply comets and asteroids from distant suns. Perhaps they were emissaries of conditions unlike any we know, born in environments where physics itself took different shapes. This parallel, two visitors in such short succession, forced reflection. Was it chance that the solar system had received back-to-back messengers after billions of years of silence? Or was it inevitability, a sign that interstellar fragments are more common than we imagined, slipping through unseen, rewriting our assumptions with every passage? Oumuamua had startled, Atlas disturbed. Together they whispered that the sky beyond our sun may be far stranger than we had ever dared to believe. The laws of cometary physics are supposed to be familiar. Icy bodies wander close to the sun, heat infiltrates their cores, and jets of gas erupt, tearing weak structures apart. Yet 3I Atlas refused to follow that script. Its disintegration came early, abrupt, and strangely inconsistent. Astronomers tried to explain it through ordinary mechanisms, volatile ices sublimating unexpectedly, hidden fractures widening under centrifugal spin, but the evidence would not settle into the expected patterns. The break itself unfolded with unusual complexity. Instead of one catastrophic explosion, Atlas unraveled in stages, a slow erosion of coherence that stretched across weeks. Its nucleus fractured into several large pieces, each disintegrating again, as if the object was built not of one body, but of many, tenuously bound. Thermal models failed to account for how little sunlight it had absorbed when the disintegration began. The calculations showed it should have been stable at that distance, too cold for such violence. Even stranger were the velocities of its fragments. Jets of sublimated gas could, in theory, push debris outward in erratic directions, but Atlas's pieces accelerated with puzzling variance, as if guided by hidden instructions. Some seemed propelled too forcefully, others hardly at all. Observers noted subtle anomalies in brightness, fluctuations that hinted at uneven, perhaps asymmetric forces, but the equations struggled to catch the complexity. It was in these inconsistencies that suspicion grew. A simple comet should obey the thermodynamic logic of fragile ice. Atlas did not. Its breaking was too early, its dispersal too chaotic, its motions too irregular. It was not that the object violated physics outright, but it stretched familiar rules until they seemed almost inadequate, as though reality itself were reluctant to contain this traveler. Atlas did not merely shatter, it challenged. In the fragments left behind was not the predictable signature of celestial decay, but the unsettling suggestion of something more, a breakage that felt like a question posed directly to the universe. The language of the cosmos has always been written in gravity. It binds the planets to their orbits, cradles the moon around Earth, sculpts galaxies into spirals. It is the one law we trust to hold, the quiet anchor of all celestial motion. Yet 3I Atlas whispered of betrayal. Its fragments did not always move as gravity decreed. Subtle shifts in trajectory appeared, deviations so small they could be brushed aside as error until patterns began to surface. Astronomers tracked the drifting pieces across nights of observation, plotting their courses against the strict predictions of Newtonian mechanics. Some fragments drifted too quickly outward, as if nudged by invisible fingers. Others lingered in defiance, as though gravity's pull had lost its grip. Jets of gas escaping from icy fissures might explain some irregularities, but not all. The mathematics was strained thin, patched with caveats, stretched across gaps that refused to close. The unease deepened when comparisons were made to Oumuamua's unexplained acceleration. That earlier visitor had already bent our confidence in celestial mechanics, seeming to gain thrust from nothing more than starlight. Now, with Atlas, another interstellar object was misbehaving, but this time it was not sleek acceleration but chaotic fragmentation that could not be neatly reconciled with physics. If gravity is the storyteller of the heavens, Atlas seemed to be revising the script mid-sentence. What force could unsettle such a fundamental law? Was it hidden reservoirs of volatile gases, unknown weaknesses in the nucleus, or something stranger, an interaction between interstellar material and spacetime itself? For those who gazed at the faint, flickering trails of Atlas's shards, the suspicion grew quietly but relentlessly. Perhaps gravity, so constant, so loyal, was not betrayed at all. Perhaps it was revealing something it had hidden all along. In the weeks that followed its collapse, 3I Atlas transformed from a single luminous visitor into a diffuse constellation of fragments. But within this debris cloud, patterns emerged that should not have been there. When comets shatter, the pieces typically scatter in predictable arcs, following ballistic rules of momentum. With Atlas, astronomers noticed strange symmetries, groupings that seemed to echo, structures that resisted randomness. Some fragments drifted apart at near-identical speeds, as though choreographed. Others arranged themselves in peculiar alignments, briefly forming linear strands or arcs before dissolving back into haze. To the untrained eye, it looked like chaos, but to those charting every motion, every fluctuation of brightness, there was the haunting suggestion of order. Could there be information hidden in the geometry of its remains? The debris itself shone erratically. Some pieces flared brighter than expected, as if volatile ices were released in pulses rather than steady streams. Others dimmed too quickly, as though smothered by something unseen. Photometric analyses struggled to reconcile the wild swings. A broken comet should fade into obscurity, yet Atlas refused a clean ending. It lingered, its light changing in unsettling rhythms. To scientists grounded in pragmatism, the explanation was mundane: irregular outgassing, the quirks of fragile ice reacting to solar heat. Yet beneath the surface of academic caution, more speculative whispers spread. What if the fragments carried not just dust and gas, but imprints of something deeper? Could the patterns in their dispersion be more than accident? Could they represent the echoes of forces beyond our grasp? A comet should die quietly, its fragments dispersed into dust, lost among the stars. But Atlas broke differently. Its fragments were not merely remnants of destruction, they were clues, scattered like pages of a book torn apart, daring humanity to wonder whether they had been written that way. For centuries, when comets crossed the heavens, they spoke only in silence. Their beauty was visible, their chemistry sometimes sampled, but their voices were lost. With 3I Atlas, scientists strained to listen more carefully than ever before. Beyond the visible telescopes and orbital calculations, they turned to the quiet ears of the cosmos: vast radio arrays, deep space monitors, instruments designed to catch whispers too faint for human senses. They listened for signals not of communication, but of anomaly. A comet's breakup should create no unusual broadcast. It should scatter dust and ice, not emit structured radio waves. Yet teams around the world, cautious but curious, began sweeping the frequencies, seeking even the faintest irregularity. From the plains of New Mexico to the quiet deserts of Australia, antennae pivoted, chasing the faint trail of debris as it drifted further into obscurity. The silence was immense, but not empty. Cosmic noise washed through the receivers, the static hiss of the galaxy, the low thunder of distant quasars, the quiet breath of the cosmic microwave background. Amid this ocean, scientists searched for patterns, signals that could not be explained by known astrophysical sources. Days turned to weeks, and still Atlas revealed no clear voice. But the effort itself carried weight. Humanity was no longer content to simply watch these visitors. We had begun to ask if they carried messages not written in light, but in fields, frequencies, or resonances that might touch the very fabric of space. Some spoke of futility, others spoke of necessity. For if interstellar wanderers could alter trajectories, could fracture against predictions, could seem to hint at unseen physics, then silence itself became a kind of answer. Listening to Atlas became not just about detection, but about philosophy. In its quiet, it forced us to confront the possibility that meaning might exist even when words do not. The sky gave no signal, but in straining to hear, humanity revealed its own unease, a willingness to believe that even broken fragments, drifting into nothingness, might carry the weight of a question larger than our world. As the days of observation stretched into weeks, the data began to accumulate like brushstrokes on a canvas that no one could quite recognize. The comet's demise was not a single act, but a sequence, and every instrument that turned its gaze added another layer of perplexity. From optical telescopes charting the fragments, to spectrographs measuring the chemical composition of its dust, to orbital models predicting paths that refused to behave, each source of knowledge contributed to an atlas of anomalies. Chemical signatures suggested the familiar building blocks of comets: water, ice, carbon dioxide, faint traces of organics. But even here, irregularities emerged. Some ratios did not align with what was expected of icy bodies born near stars. Atlas seemed richer in certain volatiles, depleted in others, like a recipe from a kitchen not our own. Its gas emissions flared unevenly, inconsistent with standard models of sublimation. These oddities hinted at conditions foreign to our solar nursery, a chemistry shaped under alien suns. The structural behavior of its fragments remained equally unsettling. Their orbits diverged unpredictably, slipping away from one another in defiance of clean equations. Light curves showed erratic brightness, as though surfaces were turning and flashing with energies poorly understood. The more precisely scientists attempted to model the decay, the less the models could explain. Atlas was not simply a puzzle, it was a rebuke to confidence, a reminder that reality itself sometimes refuses neat simplification. By late spring of 2020, astronomers reluctantly concluded that the object could not be recovered. Its remains had scattered into dust too faint to track, yet in their hands they held terabytes of data, incomplete but intoxicating, each anomaly a fragment of a greater riddle. What emerged was not a single contradiction, but a chorus of them: too early a breakup, too irregular a fragmentation, too alien a chemistry, too defiant an orbit. Together, these threads wove a picture that did not resemble an ordinary comet. Atlas became less an object and more an event, a fleeting drama that forced science to confront not only what it did not know, but what it could not yet imagine. Every discipline has its foundations, and for astronomy, the foundations are laws as old as Newton and as resilient as Einstein. Celestial mechanics, thermodynamics, conservation of momentum, these are the bedrock upon which the sky is interpreted. Yet in the scattered remains of 3I Atlas, something felt wrong, something that gnawed at those foundations. The irregularities in its breakup, the anomalies in its fragment paths, the inconsistencies in its light curves, each by itself might be explained away. Together, they formed a constellation of defiance. The equations bent under their weight, the models frayed at the edges. Atlas did not so much violate physics as expose its incompleteness, daring scientists to see the cracks in what they thought was unshakable. Thermodynamics expected a comet's energy budget to unfold in predictable ratios: solar heating, sublimation, jets, decay. Atlas did not spend its energy according to plan. Celestial mechanics expected fragments to obey ballistic drift. Atlas's pieces danced in odd synchrony. Even relativity, distant in its reach, lurked in the background, for what if spacetime itself played some subtle role in how this visitor disintegrated? It was not just the physics of comets at stake, but physics itself. If interstellar bodies arrived carrying behaviors unexplainable by our equations, then perhaps the laws we hold as universal are merely provincial local customs of one star system, not truths written across the cosmos. That idea was quietly terrifying. Scientists are trained to resist alarm, but in late-night discussions, at conferences, and in the quiet corners of observatories, Atlas was spoken of not as a comet but as a reminder. The universe had once again leaned down and whispered, "You do not yet understand me." And for a moment, those who listened could almost feel the ground of certainty shift beneath their feet. What disturbed astronomers most about 3I Atlas was not only that it broke apart, but that in its fragments there seemed to linger an implication, patterns where there should have been none. A cometary breakup ought to be chaos. Ice sublimes, pressure builds, the structure fails, and shards scatter outward. The story should end there. Yet in the wake of Atlas, something unnerving emerged, the possibility that its presence was not passive, that it had changed the very field into which it fell. Certain fragment motions hinted at synchrony, as though invisible lines of force shaped their escape. Some brightness variations occurred in odd rhythms, almost cyclical, as if tethered to a hidden metronome. And beneath all of this lay the chilling suspicion: what if the strangeness was not in Atlas itself, but in the rules around it? Could a visitor alter the fabric of physics simply by entering? Could its chemistry, born in alien fields of gravity and radiation, act like a seed that bends local constants? Some theorists speculated in hushed tones. Perhaps an interstellar object carries with it more than material. Perhaps it brings a fragment of the laws that governed its birth system, imprinted like memory into the quantum fields that hold its atoms together. If so, then Atlas was not just breaking, it was rewriting. Its fragments, each shard of dust, might have acted like subtle instruments, perturbing the environment in ways we could barely detect. A fluctuation in spacetime curvature, a faint alteration in vacuum energy, a ripple in constants we assume to be eternal. The threat was not impact or collision, but contagion, the idea that physics could be local, temporary, mutable. If Atlas carried with it alien patterns of law, then its disintegration was not the death of a comet, but the bleeding of another reality into ours. And that possibility, fragile, speculative, yet haunting, was more terrifying than the brightest fireball across the sky. Among the more unsettling ideas born in the wake of 3I Atlas's disintegration was the possibility that its behavior was not merely mechanical, not only the product of ice and rock, but of something tied to the hidden scaffolding of the cosmos itself. The whispers of this theory traced back to one of the greatest enigmas of modern science: dark energy. Dark energy, that mysterious force accelerating the universe's expansion, remains unseen, untouchable, inferred only through its effects on galaxies. It is the most dominant ingredient of the cosmos, yet its nature is unknown. Some theorists wondered, could an object formed in a region where dark energy behaved differently carry its influence with it? Could the shards of Atlas be entwined with fields that interact faintly with spacetime itself? The idea was not fantasy alone. Certain models propose that dark energy arises from fluctuations in quantum fields pervading every point of space. If interstellar matter is born in regions of altered vacuum density, its internal structure might resonate differently with our own cosmic environment. To our instruments, this might look like anomalies, fragments drifting oddly, light curves flickering, a body breaking apart sooner than expected. And if this were so, then Atlas was not just a visitor, but a probe of sorts, unintentional, natural, but profound. Its disintegration might have been the visible echo of dark energy intruding into our local neighborhood, a faint disturbance of a sea we scarcely recognize. The notion was frightening because it was intimate. Dark energy is usually considered a grand, cosmic-scale mystery shaping the fate of galaxies. But Atlas suggested it might touch the small and fragile, too, a comet's nucleus, the orbit of fragments, the silence between radio waves. In that moment, the divide between the vast and the immediate collapsed, and the accelerating universe seemed to whisper through a broken body of ice and dust. If dark energy was the grand cosmic-scale suspect, another idea unfolded at the microscopic frontier: the possibility that the very fragments of 3I Atlas carried quantum seeds, not seeds of life, as once romanticized in panspermia theories, but seeds of spacetime itself. Physicists know that beneath matter and light, beneath even gravity, lies the restless foam of quantum fields, fluctuations that shape every particle, every atom, every motion. Some theorists began to imagine that Atlas, born in alien fields under conditions unlike our own, might carry imprints of different fluctuations. Its very ice and dust could encode tiny variations in the way spacetime vibrated. As the comet shattered, those imprints might have been released, like spores scattering into a new environment. Could such seeds alter the vacuum they entered, however subtly? Could they trigger resonances in the fields that form our own cosmos? This idea bordered on the poetic, yet it drew strength from real physics. Quantum fields do not end at planetary boundaries. They are universal, yet also mutable, shaped by unknown conditions at the birth of the universe. To some, Atlas became a metaphor for contamination, an object arriving with laws folded inside it, releasing whispers of an alien quantum signature into ours. To others, it was an opportunity, a natural experiment delivered from another star, testing whether our reality is stable against intrusion. The comet's irregular breakup became a stage on which these fears and hopes played out. Each fragment was not merely a shard of ice, but a possible carrier of hidden codes, quantum patterns invisible to telescopes, but perhaps inscribed in the way spacetime itself trembled. What if the debris cloud of Atlas was not a death, but a seeding? What if in its unraveling, reality itself was being rewritten in ways we had not yet learned to measure? The deeper scientists gazed into the puzzle of 3I Atlas, the more unsettling the speculations became. Among them was one thought that seemed to hover at the border between science and philosophy. What if the comet's strange behavior was not merely physical, but computational? The suspicion carried the flavor of the holographic principle, a profound hypothesis in physics, suggesting that the universe itself may be a projection, that all of spacetime, every star and particle, could be encoded like information on a vast cosmic screen. If reality is holographic, then interstellar objects like Atlas might act as tests of its boundaries. Its disintegration, too early and too erratic, could have been less about ice and heat and more about contact, a kind of stress test at the edge of the simulation. Just as a digital rendering glitches when new elements press its limits, perhaps Atlas revealed the edges of our universe's code. Physicists like Gerard Hooft and Leonard Susskind have long explored the idea that the world we know is a lower dimensional projection of a deeper informational fabric. In that context, the behavior of 3I, Atlas, becomes more than anomaly. It becomes evidence. What if its origin in another system meant it carried instructions from a different rendering, and upon crossing into ours, the mismatch tore it apart? Its fragments would then be not only debris but error messages scattered across the sky. The thought is chilling because it reframes observation itself. Every telescope, every measurement becomes less about discovering natural law and more about debugging a cosmic machine. Atlas, crumbling in its impossible way, might not have been just a comet at all. It might have been the universe whispering that beneath the stars there is code, and that code is not seamless. In this possibility lies a haunting question. If Atlas was a test, then who or what is running it? The shadow of Einstein stretched silently across every conversation about 3I Atlas. His general theory of relativity, the language of spacetime itself, has reigned for over a century as the great framework for celestial motion, black holes, gravitational waves. Yet here, with this fragile interstellar wanderer unraveling before it should, even Einstein's vision seemed to tremble at the edges. If relativity describes how mass bends spacetime and how energy shapes the geometry of the cosmos, then what are we to make of an object that disobeys the gravitational scripts written into the stars? Some speculated that the trajectory shifts and fragment motions of Atlas might be subtle ripples in spacetime itself, disturbances not from local forces, but from stresses carried with the comet across interstellar gulfs. Imagine Atlas as a pebble dropped into a still pond, except the pond is spacetime, and the ripples extend not outward but inward into the very constants that govern our reality. If its material was infused with foreign conditions of curvature shaped under alien suns, alien gravitational landscapes, then perhaps its entry into our domain resonated strangely with the geometry Einstein described. The result could be fragment paths that bent oddly, accelerations that did not align, decay that arrived too soon. Physicists who dared to push further wondered whether Atlas was not simply a comet, but a mirror, showing us that relativity, so beautifully successful, may not be the full story. Perhaps spacetime is not smooth and universal, but textured and provincial, each stellar region leaving its own imprint. Atlas could then be seen as a shard from another chapter of relativity, carrying within it a distorted echo of geometry foreign to ours. Einstein had warned that no theory is final, that reality will always humble its interpreters. In the fractured body of 3I Atlas, some saw exactly that humility, spacetime itself flexing, whispering that its canvas may hold folds we have yet to name. If the whispers of dark energy and holographic boundaries unsettled the mind, there was one speculation that chilled it outright: vacuum decay. It is the quiet nightmare tucked inside quantum field theory, the idea that what we call the vacuum empty space itself may not be truly stable. Instead, it might rest in a precarious state, a false vacuum, doomed someday to collapse into a lower, truer energy form. Should that collapse begin, it would ripple outward at the speed of light, rewriting the laws of physics in its wake, extinguishing atoms, stars, and thought itself in silence. In Atlas's breaking, Some theorists glimpsed the faintest echo of that threat. If its material was imbued with conditions foreign to our vacuum, then its disintegration could have been more than heat and ice. Perhaps it was a clash of vacua, the unstable touching the stable, a tremor in the quantum fields beneath existence. Each fragment scattering could have been less debris and more ripple, testing whether our cosmos could absorb its intrusion without fracture. Stephen Hawking once warned of such possibilities. He imagined that high-energy experiments, or even cosmic events, might trigger vacuum collapse. And while Atlas's faint, fading light did not end the world, its strange behavior provoked an unsettling question. What if interstellar wanderers are more than relics of other suns? What if they are carriers of other vacua, shards of realities unstable against our own? The terror lies not in immediacy, but inevitability. A single seed of false vacuum, should it form or be introduced, would consume all we know without warning. Atlas, in its fragile unraveling, became a symbol of that fear, not proof, but reminder. That reality itself is conditional, that the laws we trust may be temporary, that the sky could change, not with fire or impact, but with silence swallowing silence. If vacuum decay painted the darkest nightmare, another speculation reached outward with equal strangeness but less finality, that 3I Atlas was not of our universe alone. Its chemistry, its early death, its chaotic fragments, these became seeds for a thought that perhaps it was not merely foreign to the solar system, but foreign to the very set of laws we inhabit. The idea of the multiverse, once philosophy's dream, had become physics speculation. From inflationary cosmology to string theory landscapes, countless models suggest that our cosmos may be one bubble among many, each with its own constants, its own rules, its own definition of reality. If so, then an interstellar traveler like Atlas might be more than a fragment from another star system. It could be a shard that slipped across cosmic boundaries, a relic born under a sky where physics was written differently. Its strange disintegration could then be the signature of incompatibility. In its own cosmos, perhaps Atlas was stable, coherent, whole. Crossing into ours, it fractured its atoms, straining against laws that did not match. Its debris cloud, its inexplicable velocities, its premature demise might not be errors of measurement, but the slow unraveling of a body mismatched to its host universe. To entertain this was to confront a dizzying thought. If matter can bleed across universes, then borders are not sealed, and if borders are not sealed, then physics itself is porous. What we call constants might not be constant at all, but local dialects in a larger chorus of realities. Atlas, crumbling as it passed through our sky, might have been the first visitor to carry the scent of another universe. If so, it was not simply an interstellar comet. It was a messenger from a parallel world, one that left us nothing but questions in the dust of its fading trail. While theories swirled in journals and conference halls, there was another, quieter story, the human story of those tasked with interpreting 3I Atlas. The astronomers, physicists, and theorists found themselves caught in a dilemma as old as science itself: how to balance sober, empirical caution with the rising weight of philosophical unease. Publicly, the language remained careful. Atlas was a fragile comet, its breakup consistent with the unpredictable nature of icy bodies. It was a data point, interesting but not alarming. This was the posture of restraint, the shield against speculation that might discredit entire fields. But in private conversations, a different tone emerged. Scientists spoke of the irregularities not as solved puzzles but as lingering shadows. Some admitted sleepless nights, replaying orbital models that refused to align, or staring at fragment velocities that gnawed at Newton's laws. The dilemma was more than academic. To accept Atlas as ordinary was safe, comforting, but perhaps dishonest. To voice the deeper unease was risky. It could invite ridicule, accusations of sensationalism, or derail careers. Yet behind closed doors, some confessed that Atlas seemed almost too strange, too deliberate, its timing uncanny, its echoes, with Oumuamua, unsettling. There is a loneliness in science when data brushes the edge of philosophy. It forces those who observe to ask questions not only of the sky, but of themselves. Should they protect the public from uncertainty, or should they admit that the cosmos had delivered something they could not yet explain? Thus, the watcher's dilemma grew heavy. Each night, telescopes turned, instruments hummed, data flowed. Yet in the silence between observations, the scientists themselves bore the weight of knowing that they were not just measuring dust. They were confronting a possibility that Atlas, in its quiet death, had unsettled the foundations of reality itself and left them as reluctant messengers of that truth. The unraveling of 3I Atlas demanded pursuit, not just with eyes turned to the night sky, but with the full arsenal of humanity's instruments. Across continents and in orbit, telescopes shifted their gaze, detectors sharpened their ears, and spacecraft recalibrated their sensors, each straining to extract meaning from the vanishing ghost. Optical telescopes charted the fragments in exquisite detail, from mountaintops in Hawaii to the deserts of Chile. Spectrographs teased out the comet's chemistry, revealing a signature that was both familiar and alien. Infrared instruments sought the faint warmth of its dust, mapping the thermal echoes of a body already dissolving. Every wavelength became a voice in the chorus of inquiry. Beyond Earth, spacecraft played their role. Satellites like Hubble peered with precision, recording images of the crumbling nucleus as it shed its pieces into the void. Other observatories turned briefly from galaxies and nebulae to trace the humble smudge of Atlas, as though sensing the gravity of its mystery. Even missions not designed for comets found themselves contributing. Detectors of cosmic rays, monitors of solar particles, each asked to listen for anomalies that might align with Atlas's crossing. On the ground, particle detectors joined the chase. Some theorists speculated that the comet's material, interacting with Earth's magnetic shield, might leave faint imprints detectable as cosmic ray anomalies. Others searched for perturbations in neutrino fluxes, the quietest messengers of all. Though no definitive signal arose, the attempt itself revealed the seriousness with which Atlas was pursued, not as debris, but as a possible key to hidden laws. Every tool became a thread woven into a larger tapestry of vigilance. Together, they formed not just a scientific campaign, but a collective act of reverence, humanity's instruments bending toward a single broken traveler, refusing to let it vanish without testimony. In their hum and calibration, there was an echo of awe, the recognition that sometimes even the faintest object carries the weight of the infinite. While telescopes traced its fading light, another front of inquiry unfolded far from the skies, deep underground, and within the magnetic coils of particle colliders. Some physicists wondered if the strange behavior of 3I Atlas could be echoed not in space, but in the controlled violence of laboratories on Earth. The Large Hadron Collider, that vast circular machine beneath the Franco-Swiss border, became an unlikely companion in the pursuit of an interstellar ghost. The question was subtle. If Atlas's fragments hinted at hidden fields, could those fields resonate with the energy densities created in particle collisions? When protons slam together at near light speed, the resulting showers of particles and quantum fluctuations might momentarily reproduce the conditions that tore Atlas apart. Could there be faint correspondences, unexplained resonances, statistical anomalies, signatures of fields beyond the standard model? It was fitting that one of the collider's principal detectors bore the same name, Atlas. Within its massive layers of silicon and magnets, physicists sifted through billions of collisions, watching for deviations, for traces of unknown particles or forces. None declared a direct link, but whispers emerged of data that might one day speak the same language as the comet's death, hints of unstable vacua, fleeting fluctuations in dark sector candidates, anomalies at the margins of error. Though speculative, the effort underscored a growing unease. Perhaps the cosmos and the collider were mirrors. The disintegration of a distant comet and the high-energy births and deaths of particles might both be telling the same story, that reality is more fragile than assumed. Thus, Atlas existed in two domains at once, one shattered among the stars, one buried beneath the earth. And in both, the same question echoed: are we seeing the boundaries of known physics, or the first trembling signs of a deeper, hidden order? When the dust of 3I Atlas began to fade from the view of Earth's mountaintop observatories, a new sentinel lifted its gaze: the James Webb Space Telescope. Unlike the ground-based surveys bound by atmosphere, Webb floated in silence at the L2 point, a million miles from Earth, designed to stare into beginnings of galaxies, the chemistry of exoplanets, and the earliest light of creation itself. Yet for a time, its golden mirrors were asked to witness something more modest: the crumbling remains of an interstellar traveler. The Webb telescope, with its extraordinary sensitivity in the infrared, could read the faint warmth of dust long after the comet's nucleus had disintegrated beyond recognition. To most instruments, Atlas had vanished, reduced to a smear too faint to measure. But Webb could still discern the dying glow of fragments, still chart the chemistry of the gases released. In its spectral lines, it traced an imbalance: volatiles that hinted at alien origins, molecules that suggested the comet had been formed in conditions unlike those of our solar nursery. More striking still was the silence Webb confirmed. No peculiar emissions, no unexpected radiation, only the faint, steady bleed of a comet dissolving into anonymity. Yet within that quiet light, astronomers glimpsed something sobering: the persistence of anomaly. Ratios of gases remained odd, fragment behavior continued to resist simple models, the signature of foreignness remained etched even in its death. The telescope became less an instrument and more a witness, recording the final whispers of an object already too faint for others to follow. Its vigil underscored the paradox of Atlas. Even in its nothingness, it unsettled. Even in its silence, it questioned. For Webb, designed to look back billions of years into the dawn of time, 3I Atlas was a fleeting afterimage. But for humanity, those last glimpses were enough to keep alive the suspicion that in the comet's trail, the universe had revealed a shadow of something larger than we can yet name. Among the fragments of dust and silence, whispers began to circulate of papers not meant for public release. Inside NASA, as within every great institution, there are layers: the outward-facing reports crafted for public clarity, and the deeper, internal documents where speculation breathes more freely. In the wake of 3I Atlas, such papers emerged like ghosts in the corridors of scientific rumor. They did not speak in dramatic proclamations, nor did they confirm the stranger theories. Instead, they questioned: could the unusual breakup of Atlas indicate that interstellar objects might not be inert, but active carriers of unfamiliar physics? Was it possible that debris from beyond the sun carried not only different chemistries, but interactions unknown to terrestrial laboratories? One memo reportedly asked, if an interstellar body altered the constants of local physics, how would we know? These questions were posed not for the public, but for engineers and mission planners. Should the next interstellar visitor be pursued by a probe? Should instruments be designed not only to capture images and spectra, but to measure the surrounding fields of space itself? Atlas had revealed that traditional cometry models might be inadequate. The next step, some argued, was to prepare for the possibility that such objects could be probes of physics itself. The speculative tone of these documents carried risk, which is why they rarely surfaced beyond quiet meetings and internal channels. To speak too openly of reality-shifting comets was to court misunderstanding. Yet in private, even conservative voices admitted Atlas had raised questions not easily dismissed. Thus, the hidden papers were less about conclusions than about courage. They were the written traces of scientists willing to wonder aloud what others dared not, that a broken comet might be more than a frozen relic, and that in chasing such wanderers, humanity might stumble upon the deeper architecture of reality itself. Though Stephen Hawking passed away 2 years before 3I Atlas appeared, his voice lingered in the shadows of the conversation. For decades, he had warned of the fragile balance of the cosmos, the instability of vacua, the risks of particle accelerators, the terrifying possibility that the universe might not be as stable as we believe. In Atlas's fractured body, those warnings seemed to echo. Hawking spoke often of horizons, both literal and metaphorical. He showed us how black holes could evaporate, how singularities challenged the continuity of spacetime, how the very fabric of existence might someday reveal its temporary scaffolding. If the cosmos was precarious at its core, then interstellar visitors like Atlas were reminders of how little control humanity possesses. Their anomalous behavior could be chance, or it could be a subtle tremor in the foundations Hawking described. The idea of vacuum decay had been one of his most sobering speculations, that a bubble of lower energy vacuum might form and consume reality at light speed. Atlas, in its early and chaotic disintegration, seemed to dramatize that thought in miniature, not a world-ending event, but a symbol, an omen of fragility. It reminded scientists that the universe is not guaranteed safe or eternal. It is dynamic, unstable, alive in ways we scarcely understand. In memorial lectures, in archived writings, Hawking's words found new resonance. He had urged caution with high-energy experiments, not from superstition but from a deep respect for how little we know. And here, a comet born in another system fell apart in ways that seemed to underscore his caution. To some, it felt as though Hawking's ghost was leaning over the moment, whispering that the universe's mysteries are not abstract equations, but forces that arrive uninvited, fragile, and real. Atlas became not only a scientific puzzle, but a philosophical echo, a broken body in the sky that reminded us of Hawking's greatest gift, the insistence that we must always look at the cosmos with humility, because reality itself may not be as firm as we hope. Long before telescopes traced comets through the dark, humanity looked up and saw them as omens. In the ancient skies, a streak of light was rarely neutral. It was a sign, a portent, a message from powers beyond. Chinese chronicles recorded comets as broom stars, sweeping away dynasties. Roman historians saw them as harbingers of the deaths of emperors. In medieval Europe, their sudden arrivals filled the air with dread, as though the heavens themselves had turned against human order. 3I Atlas, to modern scientists, was a broken comet, an interstellar traveler, undone by stresses we could not fully explain. Yet its haunting anomalies reawakened something older, deeper. For when the public glimpsed its fractured beauty, drifting in images across headlines, the echoes of myth stirred again. Was this not what our ancestors had always intuited, that objects arriving from the deep sky carried with them a kind of power, a disruption, a change? In stories told around ancient fires, comets were not just ice and rock. They were messengers, sometimes divine, sometimes catastrophic. Some cultures saw them as bridges between worlds, carriers of cosmic will. To revisit those myths in the age of Atlas was not superstition but resonance, for here was a real comet that behaved as though it carried strangeness, as though it were not content to obey the natural laws we assumed. Scientists may measure fragments and spectra, but human memory interprets more. Atlas was framed in equations, yes, but it was also framed in story, the continuation of a lineage where comets remind us that we are not in control, that the sky can still surprise us, that reality can still bend. Thus, Atlas did more than puzzle physics. It stirred the ancient reflex of awe and fear, weaving modern science into a much older tapestry of myth. Once again, a broken comet became both data and omen, a reminder that across centuries, humanity has always seen in the heavens not only what is, but what it means. What unsettled even the most cautious minds was not merely the data nor the echoes of myth, but the sheer terror of possibility. If 3I Atlas truly altered reality even in the smallest way, then the rules of existence were no longer guaranteed to be stable. Imagine constants shifting by fractions of fractions, imperceptible yet profound. The fine structure, constant drifting, the electron's charge trembling, the speed of light adjusting by the smallest degree. Life would not explode in chaos. It would simply fail, molecules unraveling, chemistry ceasing to bind, stars burning differently. This was not science fiction. It was the rational extension of what physicists had long feared, that the universe is not immutable, but conditional. Theories of false vacuum decay, multiverse landscapes, quantum instabilities all pointed to a cosmos that might, under pressure, rewrite its own laws. Atlas's strange disintegration gave form to those fears. It was no longer a thought experiment in equations, but an image, a visitor shattering against the invisible framework of our reality, hinting that the framework itself could break. For most of humanity, this possibility remained distant, abstract, but for the few who looked closely, the unease was personal. If reality could shift, then everything thought, memory, history could dissolve, not in fire, but in erasure. Time would have no witness, consciousness would never know the moment of its end. That is the horror vacuum decay carries, and that Atlas came to symbolize, not destruction, but the undoing of context itself. In the terror of this possibility lies a paradox. It awakens despair, yes, but also reverence, for if reality is fragile, then every moment of its stability becomes a gift. The fragility of Atlas reminded humanity of the fragility of existence, of the delicate balance upon which life is poised. The comet became not only a threat, but a teacher, one that forced us to feel, perhaps for the first time in centuries, the precariousness of being. Time has always been the most reliable arrow, a one-way current dragging every particle, every thought, every star from past into future. It is the rhythm we inhabit, the silent metronome of existence. Yet the strange unraveling of 3I Atlas forced some to ask the most unsettling of questions. What if even time itself is fragile? In the chaotic break of its nucleus, in the odd drift of its fragments, in the inconsistencies of its light curves, there were those who imagined not just disruptions of gravity or chemistry, but disturbances in causality. If matter born in another system carried with it different rules, different vacuum densities, different quantum seeds, then perhaps it also carried a different flow of time. In crossing into our domain, that current might not align. What would it mean if time flowed slightly differently around Atlas? If its fragments existed half a breath out of sync with the surrounding cosmos? Perhaps its premature shattering was not destruction at all, but the visible symptom of temporal misalignment, a body unraveling because its clock ticked against ours. Theories of relativity already teach us that time dilates, bends, stretches with motion and mass. What if interstellar matter, born under alien horizons, brought with it a local arrow of time, now colliding with our own? The terror of such speculation is profound. If time is not universal, then cause and effect themselves become negotiable. The sequence of history could waver, memory could fracture, the universe could refuse to move in one direction. Atlas, dissolving in silence, might have been the faintest echo of such instability, not enough to end us, but enough to remind us that time's constancy may be no more secure than the comet's fragile body. And so the arrow of time, once thought inviolate, now seemed like another rule written in pencil, ready to be erased by a fragment from beyond. For those who bore witness to the passing of 3I Atlas, the weight of knowledge was not abstract. It pressed into the lives of the scientists themselves, into the quiet hours after data was logged, into the conversations they hesitated to share. Knowledge is not always liberation. Sometimes it is burden, and with Atlas, the burden lay in knowing that the sky might not be governed by rules as firm as they had believed. To publish only the measured facts was safe. A fragile comet, an early breakup, anomalies that fit within margins of error. But beneath the caution, the deeper unease remained an intuition that something larger had been glimpsed. For some, this tension became almost unbearable. To admit too much risked ridicule, the collapse of credibility, careers undone by accusations of sensationalism. To admit too little risked silence, the burying of a mystery that might never return. The history of science is filled with such moments. Galileo hesitated before releasing his findings. Einstein worried over contradictions in his own work. Hawking confessed unease at the implications of instability. Atlas placed modern scientists in that lineage, forcing them to stand at the border between what could be said and what could only be felt. The burden grew heavier because the comet was gone. There would be no second chance, no return visit, no probe dispatched to sample its dust. All that remained were observations of a dying light and models that resisted coherence. It was as though reality had offered a question and then withdrawn before an answer could form. To hold that in silence was perhaps the cruelest part. For behind the official reports, behind the technical papers, behind the polite conference slides, lay a truth unspoken that Atlas had unsettled the ground of certainty, and those who saw it most clearly were condemned to carry that knowledge alone. The comet was gone, scattered into dust, invisible to the naked eye, yet its absence spoke more loudly than its presence ever had. 3I Atlas was not the first of its kind. It had followed Oumuamua, and it would not be the last. The universe is vast, and the solar system is not sealed. Fragments from other suns, other nurseries of matter, and perhaps even other realities will inevitably pass through again. The question is not whether, but when and what they will bring with them. Astronomers have already estimated that countless interstellar objects traverse the galaxy, silent wanderers slipping between stars like seeds on a cosmic wind. Oumuamua startled us with its strangeness. Atlas unsettled us with its fragile death. The next may come larger, brighter, or even more alien in its behavior. Humanity now waits with instruments sharpened, telescopes ready, models revised, a vigil across the sky for the next messenger. But the anticipation is shadowed by unease. What if the next arrival carries not hints but proofs? What if it fractures in ways even stranger, or accelerates without cause, or alters the fields around it? Each new visitor could peel back another layer of certainty, showing us that what we call natural law may be only provisional. And if one day a fragment arrives that does not pass harmlessly through, but lingers, or interacts, or changes the fabric of our world, then humanity will face a truth it has long suspected but rarely confronted, that the cosmos is not a distant stage, but an active presence, capable of rewriting the script of our reality. In this certainty that another stranger will come lies both fear and hope. Fear that it may threaten all we know, hope that it may answer the questions Atlas left behind. Either way, the next visitor will not be ignored. The universe has spoken twice already. Humanity listens now with an intensity it never has before. The trail of 3I Atlas has long since vanished into darkness, its fragments now dispersed into the silence of interstellar space. Yet the echo of its passing lingers. For in the brief weeks of its unraveling, it forced us to look not only outward, but inward, to confront the fragility of the laws we trust and the uncertainty of the ground upon which our reality is built. It arrived unannounced, as all comets do, but it departed as something greater than an object. It became a question, a mirror held to humanity's faith in permanence. Why did it break so soon? Why did its fragments move as though under laws not fully ours? Was it merely fragile ice? Or was it something deeper, something stitched into the fabric of spacetime itself? We may never know. Perhaps Atlas was nothing but dust and coincidence, its mysteries illusions painted by incomplete data. Or perhaps it was the first true hint that the universe is not singular in its rules, but a mosaic of shifting truths, each fragile, each conditional. As its final dust trails dissolved into the void, humanity was left with silence. But silence, too, is meaning. Silence says that the universe does not answer in our time, only in its own. It reminds us that every glance at the night sky is an act of humility, that to observe is to admit we do not yet understand. The fragments are gone, the data remains, and with it, the haunting possibility that in watching Atlas die, we witness not the end of a comet, but the edge of reality itself. And now, as the script fades, so too does the comet. The last grains of its dust dissolve into darkness, their light too faint to ever return. The sky closes again, serene, unbroken, as though nothing had ever passed. But in our memory, the visitor lingers not as fear, not as threat, but as a gentle reminder of fragility. The universe is vast, and we are small, yet in that smallness lies wonder, the capacity to notice even a broken traveler and to weave meaning from its brief existence. We are left not with answers, but with awe. With each breath beneath the stars, we borrow stability from a cosmos that might one day shift, but tonight it holds. Tonight, the arrow of time moves forward, steady and silent. And so the story ends not with terror, but with calm. The stranger has passed, reality has endured, and humanity returns to its eternal vigil beneath the stars. May we carry the lesson of Atlas gently, that every moment of stability is precious, and every question it left behind is an invitation to wonder. Sleep now, beneath the unbroken sky. The universe still holds you,